Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Here we are required to evaluate the orthographic projections of a line which happens to be parallel to the profile plane. So since this line happens to be parallel to the profile plane, so to begin with, we are going to obtain the true length projections of this line onto the profile plane to begin with. And thereafter, we will be evaluating the front view projections and the top view projections of this particular line. So here we have been provided with a line RS for which end R, it happens to lie 50 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. Whereas the end S of the line, it is lying 20 millimeter above the horizontal plane and 55 millimeter in front of the vertical plane. And this line RS, it happens to be parallel to the profile plane. So to begin with, we are going to evaluate the true length projections of this line onto the profile plane, and thereafter we will be evaluating the front view projections and the top view projections of this particular line. So first of all, we are going to evaluate and obtain the spatial coordinate locations of the 2 points R and S in the 3D space using horizontal plane, vertical plane and the profile plane. So here we have got XY reference line over here, and this is the X1 Y1 reference line that we have got. So we know that the coordinate locations of the end R and end S, they have been provided to us. So we know that end R, it is lying 50 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So we can see that this point R, we are going to locate 20 millimeter in front of the vertical plane and 50 millimeter above the horizontal plane. So the spatial coordinate location corresponding to the point R has been obtained in the 3D coordinate system. Now similarly, we know that point S, this is lying 20 millimeter above the horizontal plane and 55 millimeter in front of the vertical plane. So we have located point S 20 millimeter above the horizontal plane and this is 55 millimeter in front of the vertical plane. And since this line RS happens to be parallel to the profile plane, so now we can join points R and S in the 3D spatial environment like this. So having obtained the coordinate locations over here, now what we can do, we have to obtain the true length of this particular line onto the profile plane. So the true length projections of this line RS will be obtained onto the profile plane when the observer is going to look at this particular line from the left hand side direction. So when the observer is looking at this line from the left hand side, so these points R and S, they will be projected onto the profile plane at these two positions. So this position will be labeled as point R double dash, and this position or projection of the point S onto the profile plane will be labeled as S double dash. Having obtained the location of the points R double dash and S double dash onto the profile plane as projections corresponding to the points R and S, we can join the points R double dash and S double dash so that we can obtain the true length projections of this particular line RS onto the profile plane. Now we can observe over here that this line RS, it is an oblique line which happens to be inclined to both the horizontal plane as well as the vertical plane. So therefore, the front view projections of this line RS onto the vertical plane will be revealing its apparent length or the foreshortened length R dash S dash in the vertical plane. Similarly, the top view projections of this line onto the horizontal plane will be again revealing the apparent length of the line in the top view. So let us evaluate the front view as well as the top view projections of this particular line RS on the reference plane. So once we have obtained this left hand side view, now we are going to observe this line from the front direction. So when the observer is going to look at this line from the front side, so this point R will be projected onto the vertical plane at this particular position. So name of this point will be R dash. Similarly, point S will be projected onto the vertical plane, that is the front view projection, as S dash. So once we obtain these 2 points R dash and S dash, so we can join points R dash and S dash. Therefore, we are going to observe the apparent length projections of this particular line onto the vertical plane. So this is the foreshortened view of this line on the vertical plane. Why? Because this line RS is an oblique line and it is inclined to the vertical plane. Now similarly, this line, it is also inclined to the horizontal plane. So when we are going to look at this line from the top view direction, so this point R, it will be projected onto the horizontal plane at this position. So this point name will be R in the top view, that is onto the horizontal plane. Similarly, this point S, it will be projected onto the horizontal plane at this position. That is, this will be the point S over here in the top view. So having obtained these 2 points R and S in the top view, so we can join these 2 points in the top view. And this projection in the top view, which is obtained on the horizontal plane, this will once again reveal the apparent length projections of this line RS. So this way we have obtained the left hand side view projections, which represent the true length of the line, the front view projections, which reveal the apparent length of the line, and the top view projections of this line RS, which again reveal the apparent length of this particular line. Now we need to establish the relationship between all of these 3 views. So in order to establish relationship between front view and top view, so another construction line or a projector line we need to draw. So the moment we draw these 2 projector lines, so we will be able to establish the relationship between front view and top view projections corresponding to this line RS. Similarly, in order to obtain the correlation between front view projections of the line RS and the side view projections of the line RS, so these 2 construction lines, they need to be drawn over here. So this way we will be able to establish relationship between point R, and similarly over here, once we join the projector lines over here, we will be able to obtain the relationship between top view and side view projections of this particular line. Similarly, we need to join these 2 projectors as well, so that we are able to establish relationship between the top view projection corresponding to the point R and the side view projection corresponding to the point R over here. So this way we have been able to complete the left hand side view, front view and top view projections, and we have also established the relationship between the front view, top view and side view projections of this line RS over here. Now let us proceed with the construction of the orthographic projections of this particular line. Now as we know that this line RS, it happens to be parallel to the profile plane. So we are going to start with the construction of the side view projections to begin with. So this is the profile plane. So onto the profile plane, so we have to draw the coordinates of point R and point S. So we know that end R of the line RS, it is at a height of 50 millimeter above HP and 20 millimeter in front of the vertical plane. So just see, at a height of or at a distance of 50 millimeter above the XY reference line or above the horizontal plane, we have drawn a horizontal locus line. Similarly, the distance of 20 millimeter in front of the vertical plane also we have marked over here. So wherever these two construction lines, they are going to intersect with each other, this point will provide us with the side view projection corresponding to the point R, that is R double dash. Similarly, we know the coordinate location corresponding to the point S, that is point S lies 20 mm above HP. So please check, we have marked the distance of 20 millimeter above the horizontal plane. So another locus line we have drawn over here. Similarly, point S, it is at a location of 55 millimeter in front of VP. So 55 millimeter in front of VP, we have drawn another construction line or the locus line corresponding to the point S. So wherever these two locus lines, they intersect with each other, we obtain the location of the point S in the side view, that is S double dash has been obtained. So we can check R double dash point, it is available with us at a height of 50 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. Similarly, point S double dash, it is lying 20 millimeter above the horizontal plane and 55 millimeter in front of the vertical plane. So having obtained the points R double dash and S double dash in the profile plane projections, so we can join R double dash with S double dash. So the true length corresponding to the line RS has been obtained over here. So these are left hand side projections which are available with us as a true length in the side view. Now having obtained this left hand side view, now the top view and front view projections of this particular line RS will be obtained. So now when the observer is going to look at this particular line from the top, so we will see that this point R double dash will be projected on the XY line as R over here. Similarly, this point S double dash, it will be projected on the XY reference line as point S. Now these 2 points we have to project in the top view projections using these 2 transfer lines. So we know the distance of 20 millimeter corresponding to the point R. So we will keep our needle compass over here at the point of intersection of the reference line XY and the reference line X1, Y1 corresponding to the profile plane. Now with this point as the needle point, we'll open the compass equal to 20 millimeter and draw an arc so that we can transfer this distance from the profile plane onto the top view plane, that is onto the horizontal plane. So this way, this distance of point R from the profile plane or the vertical plane has been transferred over here. Similarly, we know that this distance of point S from the vertical plane, this happens to be 55 millimeter. So we'll keep the needle of the compass over here. Open compass is equal to 55 millimeter. Again, draw a transfer arc line over here such that this distance is transferred onto the top view projection view. And having obtained these 2 points corresponding to point R and point S, now the horizontal construction lines or the locus lines will be drawn from point R and point S over here. So since we are not provided with this distance of the line RS from the profile plane, so we can choose any arbitrary distance over here. So this distance is an arbitrary distance that we can choose, and we can draw construction line over here which will provide us the location of the top view projections and the front view projections over here. So having marked these 2 points onto this construction line that we have drawn over here, now point R has been transferred from this location up to this position over here. So this will give me the location of the point R. Similarly, point S was located over here. So using this transfer line, we shifted it from the profile view to the top projection view over here. So this will give us the location of the point S. So this is point R, this is point S. So having located these 2 points R and S, so we can join R with S, and the moment we join point R with S, we are able to obtain the apparent length top view projections of the line onto the horizontal plane. Similarly, when the observer is going to look at this line from the front side, please check, whenever the observer will be looking at this line from the front side, so this point R double dash will be projected over here or over here as R dash. Similarly, point S double dash from the profile plane or the side view, it will be projected over here or over here as point S dash. So point R dash has been obtained, point S dash has been obtained. So the moment we obtain the points R dash and S dash, so the front view apparent length projections of this line we have been able to achieve. So this way we have checked that this is an oblique line which happens to be parallel to the profile plane. So to begin with, we have drawn or evaluated the true length projections of this line in the profile plane, and after drawing the left hand side view projections, we have translated these projections into the top view projections and the front view projections over here. So this way we have discussed about the spatial coordinate location of this particular line RS in the 3D coordinate system using horizontal plane, vertical plane and profile planes over here. And also we have evaluated the construction of the orthographic projections of this particular line in the side view, top view and the front view projection. So this is all for today. So I hope that through this discussion you would have understood about the procedure to locate the points spatially into the 3D coordinate system and the mechanism to evaluate the orthographic projections of this line, which happens to be parallel to the profile plane and it is inclined to the 2 reference planes, that is horizontal plane and the vertical plane. So we'll be continuing with further discussion regarding few more illustrative cases regarding the projections of the lines in the coming lectures. So thank you very much. Thanks a lot.